Alright, so this is the video for the odds. I hope to get through 14, but we'll see, time-wise. Number one, the speed of a runner on a straight trail is modeled by this. Okay, so be careful. This is the speed, where m is the runner's distance in miles from the start of the trail. What is the maximum speed? Use a calculator only where indicated. So I guess I don't have a calculator for this. So, a lot of words, but I want the maximum of this function. So, how do I find maximums? What happens at a maximum? Yeah, the slope is 0, or it changes positive to negative. You can phrase that either way. So I need a slope to work with. Except I don't like this, so before I take a derivative, I'm going to do negative 2/10 m cubed plus 9/10 m squared minus 1.2 m plus 7. That's not the derivative, that's me not wanting to deal with that 1/10 out front. Now the derivative. Negative 6/10 m squared plus 18/10 m. Now I'm realizing why I maybe should have left the 1/10 out front. Minus 1.2. I'm going to rewrite that as 12/10. This is just kind of ugly fraction work here. So I want to set that equal to 0, but before I do that, it might be wise to factor out definitely a negative, a 10 from the bottom, and a 6 from the top. So m squared minus 3m plus 2. That's a lot easier to deal with. So m minus 2 and m minus 1. So m equals 2 and m equals 1. Those are my critical points. Those are my possible maximums and minimums. But I want the maximum, so I need to figure out which one of those is the max. I think a number line with increasing and decreasing intervals will tell me who the max is. So let's plug in 0 into f prime. Let's see. That's an ugly, but it's not bad because it zeroes out everything. So I get negative 12/10. So that means f prime is negative, and then I'm just going to alternate negative, positive, negative for f prime. So what am I looking for? I'm looking for a max. That occurs when the slope changes positive to negative. So the max is at m equals 2. I'm kind of surprised that's not a choice. It's not right, but that's the m value. I need the speed, so I need to plug in 2.
Wait, do you plug it into the original?
That's a really good question. What am I trying to find? The speed, and that original is the speed, so I do need to plug it into the original. Also, if I plug it into the derivative, I'm going to get 0. So hopefully if I plug it into the derivative and get 0, I realize, wait a minute, something's not right here. I need f of 2, the speed at 2. So let's see, without a calculator that would be negative 16. 9 times 4 is 36. Minus 24, and then plus 7. This is annoying without a calculator. Let's see, 20 minus 24 is negative 4. Negative 4/10 plus 7 There it is, 6.6. Yuck.
Why did we find the derivative of speed?
Because we wanted to maximize speed. Turns out the picture was wrong.
Want to change the sign?
So I was looking for those places where the horizontal tangent line was 0. Those are my critical points. And then I went to a number line to figure out, well, is it a max or a min? That's a rough one to start out with. Number 3. The volume, optimization. The volume of a cylindrical tin can with a top and a bottom. Okay, most of the time we've been doing open top stuff. So how's that going to change things? Yeah, there'll be 2 pi r squared somewhere. So the volume is 16 pi. So pi r squared h equals 16. If a minimum amount of tin is to be used to construct the can, so that's like the surface area, like how much tin there is, find the height of the can. Okay, so surface area, there's 2 circles, so 2 pi r squared. Because pi r squared is 1 circle, and there's 2 of them. And then we talked before about unrolling the label on the can, where that's the height, and that's the circumference. So 2 circles, top and bottom, plus what I'll just call the label, I guess, 2 pi r h. And that's what we want to minimize. Right, that makes sense, because we'd like to minimize the amount of material being used here. I don't want to take a derivative yet. Why not? Yeah, 2 variables. So, would you like to solve for h or for r? H, definitely h. Oops, I left off the pi there. So, the pi's will go away, and h is 16 over r squared. Surface area is 2 pi r squared plus 2 pi r h. Two pi r squared plus 32 pi over r. Next, let's take the derivative. So 4 pi r. I have r to the negative 1. So that derivative would be negative r to the negative 2. So this would be minus 32 pi over r squared. Yeah, you've got to know your derivatives well enough to keep the process rolling, or else you get stuck. Too fast? Set it equal to 0. So 4 pi r equals 32 pi over r squared. How many algebra steps should I do at once? I'm going to multiply both sides by r squared and divide both sides by 4 pi. And I get r equals 2. Why is that not an answer choice? It asks me for the height. H is 16 over r squared. 16 divided by 4 is 4. Finally an easy one. I don't want to type it all in. You just tell me, what would I do I'm given the velocity and I'm asked for the acceleration. That's the derivative of velocity at 4. That's pretty similar to that first one on the warm-up. So that's just careful how you type it in the calculator. Make sure you're in radians. Find all the buttons, whatever v prime of 4 is. Number 7. Ooh, something similar maybe. A particle moves along the x-axis so that the position, all right, be careful, that's position. What is the velocity of the particle at the first instance the particle is at the origin? Okay, well, let's first, how do I find velocity if I've got position? The derivative. How do I know when I'm at the origin? 0, when x is 0. So I need to find where this thing is equal to 0, and I've got a calculator that will help me do that. And then I'll take the derivative at whatever spot that is. So 0.5x to the 4th, 1.5x cubed minus 2x squared plus 6x minus 1. And it didn't really give me any hints for my window. It just said t is greater than 0, so who knows if this is a good... That'll work. So I don't know what it's doing outside of this, but it doesn't really matter. The first time it hits the origin or the first time the x is 0 is right there. Second calc 0. We'll find that spot. Left bound, right bound, guess. So that happens at 0.178645. That's probably enough. So I want the slope at that spot. So the thing started low, it came up to the 0, and I want to know the slope at that spot. So second calc derivative at, I should have just saved this somewhere, but 0.178645. There were longer, more decimals to be more accurate, but on multiple choice, as long as these aren't too close to each other. D is x prime at that time. So that was kind of a tricky one, a two-step deal. You knew velocity is derivative of position, but you had to figure out when the thing was at 0. Number 9. Oh, this looks like no computations, all concept. The position of a particle moving along the x-axis is given by a twice differentiable function. Okay, x of 2 is less than 0. So that means its position is negative. X prime of 2. So what's that telling me? X prime of 2. Its velocity is negative. And x double prime, that would be its acceleration, is negative. Okay. So the particle is moving toward the origin. Oh, well, its position is negative over here. Its velocity is negative, so it's moving backwards. So it's moving away from the origin, not toward the origin, because its position is less than 0 and its velocity is less than 0. What about increasing versus decreasing speed? Good, same signs, so increasing speed. Answer D. That's a great question because it combines like 8 different things in there. Maybe you disagree. No, I did. I didn't say that's why that's not why I said it was great. It's just AP likes to do that where they combine a bunch of stuff. I mean, on the other hand, we did have some that were as easy as number 5. So like some are straightforward, some are a little crazy. Number 11. How do we get the acceleration from position? Yeah, I'll need the first derivative, and then I'll need the second derivative. And then I'll plug in pi. So that's not terrible. 13. Last one. A particle moves along a straight line. The graph of the particle's velocity. Okay, be careful. I'm looking at velocity. If velocity is positive, that means we're moving up or to the right. At what time? J, all those are constants. The graph intersects at K and M. Got it. Has horizontal tangents at J and L. For what value is the speed decreasing? So that means A and V have different signs. So let's see. A and V have different signs. What is A? If I'm looking at a graph of V, that's the slope of V. So I need the slope of V and V to have different signs. So let's see. That would be from there to there. V is positive, but the slope is negative. And over here, V is negative, but the slope is positive. So the speed is decreasing on those pink highlighted areas. So J to K and L to M. Concepts, concepts, concepts.